Getting the slide to change. We have Thomas, who is a software engineer with Bank Observatory.
Hi, how y'all doing? Wonderful. I just want to point out too that I was scheduled for 2:34 and you all are nailing it. So congrats. So yeah, my name is Thomas Chamberlain. I'm a software engineer at the Bank Observatory, and I am one of the other people that Will was talking about. So right now we're actually in the kitchen of my house on site at the Bank Observatory. So I've lived on site here for about 6 years now, and in this house the whole time. It would have been built, I don't know, probably in the 70s or so to house the growing on-site population of the observatory back then. And now it's still where a good chunk of the observatory staff lives, simply because it can be a bit difficult to find rental housing in the immediate area, as I'm sure y'all are well aware. So at the observatory, as Will was saying, we study outer space using a giant telescope that we have creatively named the Green Bank Telescope, or GBT, which is how I'll be referring to it. So scientists use the GBT and the data it produces to better understand the universe. And some of these scientists, like Will, who spoke a few minutes ago, work at the observatory itself. Others work at other institutions or universities all around the world. So we work with people from all over. Most of them are not employees of the observatory. They simply use the instrument that we maintain and make available to them for the science that they want to do. So my role there is really not scientific at all. So as a software engineer, I build things that help scientists do their science. And it's a lot of fun. The things that I build aren't tangible things, and that's why I don't have any slides. I don't really have pictures of the software that I build. These are invisible, intangible things that I create, and it can be quite hard to explain that to people, but I'm going to give it a shot. So the existence of the things that I make, if you can call it making things, really, they're confined to computers, you know, so it's like in Tron, pretty much. The problems that I solve with the software are quite real, and that's the part that is so much fun, actually helping the astronomers do the things that they want to do with the telescope is made possible by 20 years plus worth of software that you know, I have contributed to in a small way in my 6 years here, but obviously most of that preceded my tenure. So what does all that mean in practice? So I'll try to give you some examples of stuff that I've done in my time here to give you a rough idea. Sometimes the GBT gets a new piece of equipment. It gets an upgrade. So one of the things that often gets upgraded, so new things that we install, is something called a receiver. And a receiver is pretty much like the sensor in your digital camera. So it's the thing that the light actually ends up bouncing into and that we make a picture of the light with. And just like you can get a new model of camera or phone that has a better sensor or a newer sensor, we can add new instrumentation to the telescope that is fancier and does more sciencey things in some specific way. And so one of the first projects that I did my first year here was writing software that allowed a new piece of hardware to talk to the rest of the telescope. So when we are taking data, it's a lot like taking a picture of the sky. But in order for that to work, you have to coordinate all of the parts of the telescope together so that all the data that they take is kind of grouped in a sensible way, and you can make a good picture out of it later. So I had to write some software to allow this new stuff to talk to the existing software. And that took almost a year. It's a long time. It's a lot of fun. And I haven't really touched it since, but it was a fun time. Not everything that I do is actually astronomy related at all. So that would be something on the telescope doing science things. But I've also worked on something called the reservation system for the site. So we do a lot of education and public outreach here. We have a great EPO staff, and they do things like, you know, an activity called Radio Astronomer for a Day, where we bring a group of people on site and allow them to use an educational telescope that we maintain here to do radio science, a lot like you know, actual scientists did many decades ago with that same instrument. They'll do big bus tours. They'll do you know, host Boy Scout troops, all sorts of things like that. And Organizing all of that was quite difficult and was done in this kind of ad hoc email-based paradigm for a long time. And we wanted a better way to do it. So we wrote a website that allows our staff to coordinate these reservations amongst each other and also allows the general public to sign up for these activities through the internet. And so that was completely different. That was, building a website rather than building software for the telescope. So completely different technology stack, completely different experience, completely different skill set. And, that was another year. I worked on a team of 3 people for that. And we still maintain that website. I actually have an intern working on new features for that right now. She'll be working for another 4 months here or remotely. Another example, and this is what I'm actually working on right now, is a data archiving system. So the telescope takes a lot of data, which you can think of as images, although it isn't quite that until someone puts a lot of work into it to create something visual out of it. And so we got like 20 years of data that's just, in storage. And we've published papers from it. Various people have done science with it. But there's always more that can be done with historical data. And we haven't done a great job of making all of that data available to people in the past. And so what I'm working on is a way of kind of cataloging all of the data that we do have, analyzing its quality, and trying to determine a good way for people to access that data, determine which types of observations we have done in the past. Have we looked at this star before? What images are available for that star? Things like that. So those are hopefully some concrete examples of what I actually do in my role here. Not everything is project-based. So just like the telescope itself, software requires maintenance. Software is a little strange because it doesn't wear out like a physical thing in the real world. It just exists the same as it ever was forever, which can be good and bad. The bad part is that the world obviously changes around you. So software is always getting older with respect to the outside world. So we update our operating systems. Think Windows Update or an update to your Mac operating system that breaks something. And some software engineer somewhere is going to have to fix the thing that broke or make sure that it will work with the new version of Windows or Mac or whatever. So we try to keep ahead of these updates so that our software will always continue to work into the indefinite future, but it's not free. It does require work, and that part is not any fun. Nobody likes doing that, but we have to do it anyway. And then sometimes, as Will mentioned, things break. Things go wrong during observations. So I am one of the people that get called, at least for certain specific things that are my fault. If the telescope won't do the things that we want it to do, that's very bad because we want it to be taking pictures constantly, 24/7, forever. And is the amount of downtime that we have, we try to keep that to a minimum. So there's some scheduled maintenance that has to happen to keep it physically in good condition. But ideally, all the software should work all the time. That's, of course, not true in the real world. And so one of the things that I try to do is respond to things that break as quickly as possible and get things working again. So the last couple minutes, I'll talk a little bit about how I got here. It's a pretty short path. It wasn't where I expected to go, but here I am. I don't have any formal training at all in astronomy. So unlike Will, I didn't spend a decade of my life on astronomy things. I have a degree in computer science from Georgia State University. It's a bachelor's degree, and it took me 5.5 years to get that. So, I was an okay student, and here I am anyway. I found this job basically on a lark. I was just looking for jobs, and this one seemed interesting, and I applied, and I got it. And it's been kind of this amazing cascading thing since then. I never really expected to be living out here in West Virginia. I came here from Atlanta, Georgia. I didn't expect to be working in an observatory. I didn't really know what radio astronomy was. I knew about astronomy generally, but we do a very specific and confusing brand of it here where everything is kind of invisible. So I really do love it here. I wouldn't have it any other way. It's something that I'm really passionate about. And yeah, so I don't know, hopefully that helps. I know the intangible nature of what I do can make it difficult to talk about or understand what I'm doing. It makes it seem really a little complicated and scary, but it really isn't that much different than what anyone else does. I build things, I fix things, I solve problems. The things that I do are just a little bit harder to see. So That's what I got. If there's any questions, let me know. Otherwise, thanks for your time.
Yeah, thank you. Are there any questions in the chat for him?
So I see one from Ben. Do you have any advice for younger students who may want to get into coding and software? Yeah, so do as much of it as you can. It doesn't have to be professional. It doesn't have to do anything real, but there are a lot of great, like one of the ones that I got interested in recently is something called Advent of Code, which is an advent calendar of coding problems that someone puts together every year leading up to Christmas. It doesn't really have anything to do with Christmas except the theme. But it's basically a little coding puzzle, and you can solve it in whatever programming language you like. And it's a whole lot of fun if you enjoy solving puzzles. And it's the sort of thing that you probably should enjoy if you want to get into coding anyway. There's a lot of other similar things like that if you look around. But I think it's really important to make it interesting for yourself, to make problems that you're solving actually interesting and challenging, and to feel good about solving them, not just like, you know, taking courses for the sake of it or trying to get to some end goal, but trying to solve real world problems for yourself with software in challenging and fulfilling ways. That's where I would start. Will asks, what kind of software internships or other internships does the observatory have? So right now, I mentioned earlier that we are, I can speak at least for myself. So we have a software intern right now, named Swathi Mukkamala, who is working on the reservation system. She was hired in conjunction with a program called New Force, which is a arm of Generation West Virginia. And it's basically a coding boot camp that's 6 months in length and does not discriminate based on background. There's people who have no coding experience at all that go into it. There's people who have a college degree in something else and go into it. But the goal of that is to basically get you up to speed on real world technologies in web development in 6 months and kind of pop you out with some concrete things that you have done to show potential employers. And I give talks and do some mentoring through that process. And then I interview folks at the end. And if we're able, we try to hire one for 3 to 6 month internship doing web development of some kind. I know that there's other internships that you can find information about on our website that I don't really know enough about to speak to.
All right, awesome. Thank you so much for answering those questions and for giving a talk.
Yeah, no problem. Thank you so much for having me.